continue with lecture 3 of chapter 6. And if you remember from Sunday's lecture, محاضرة الأحد, we said that there are conservative forces, and just as a recap, فقط للتذكير, conservative forces have properties, and those properties are their work does not depend on the path, يعني شغلهم لا يعتمد على المسار, and their work around a closed path is zero. يعني شغلهم حول مسار مغلق شو بيساوي؟ صفر. And if you remember, I proved both properties. ثنتين أنا أثبتهم في last lecture 2. طيب, what are examples of conservative forces? Gravitational force is a conservative force. يعني قوة الجاذبية الأرضية اللي هي basically وزن الجسم هي قوة محافظة, and it is required in this course. It is included in your syllabus. Spring force, قوة الزنبرك, is a conservative force, true, but it's not required by you. In this course, we will not be dealing with spring force. Electric force is a conservative force, but it is not required in your course. So what is the only conservative force that is required from you in this course? It is the gravitational force, اللي هي قوة الجاذبية الأرضية. So any other force that you see in this course will be non-conservative. Any other force than the weight, you can take it as non-conservative, because spring force and electric force are not dealt with in this course. طيب, if we have conservative forces, this means we also have non-conservative forces. So what are the properties of non-conservative forces? They are exactly the opposite of conservative forces, meaning their work depends on the path. يعني شغلهم يعتمد على مين؟ على المسار. And the second is their work around a closed path does not equal to zero. يعني شغلهم حول مسار مغلق لا يساوي صفر. Now, those two properties are exactly the opposite of those four conservative forces. Let us see what this means. Always when you read a statement, think about it. Don't memorize it. ما تبصمها ولا تحفظها. Think about it. Understand it. Try to apply it. Imagine a sketch and see what really happens. I have this sketch here. This is straight from your book. Someone is moving a box from point 1 to point 2. ويعني حرك البوكس من نقطة واحدة للنقطة 2. This is his force, Fp. And this is the frictional force. Now, as he moves it from point 1 to point 2 along path 1, as I have written, this is path 1, the frictional force does work. Now, if he takes it through another path, which احنا حكينا the work the work depends on the path, and if he takes it through this path, which I called it path 2, yeah, friction will do a different amount of work. So if you take it from 1 to 2 over here, maybe friction does 10 joules, and maybe if you take it through the other path, friction does 15 joules. Now this means that the work friction depends on the path that you take to go from point 1 to point 2. Immediately this means that frictional force is not a conservative force, because if you remember last lecture, when we calculated the work of the weight in taking an object from point A to point C, we chose two different paths, from A to C directly and from A to B to C, and the work in both cases was the same. So gravitational force is a conservative force, but frictional force is not a conservative force. Okay, so that's what we mean by the above two properties. Now over here I just explain exactly what I have just said in words. Okay, so you can read it and have a look at it. This is just an explanation of what I said. Now I have taken an example from your book. Okay, an example from your book which says the following: an object acted on by a constant force F. يعني الجسم تؤثر عليه قوة ثابتة اللي هي F. Moves from point 1 to point 2 and back again always make a sketch. I told you, whenever you see a question, try to make a sketch. I have an object. That object is acted on by a force. It took it from point 1 to point 2. This is a path from point 1 to point 2. And then it took it back to point 1. Maybe you choose this path, whichever path you want to choose, it's up to you. But you started from point 1, you moved, and then you came back to point 1. I chose this path. We call this a closed path. This is closed path. بيحكي لي ليش سميته closed path؟
displacement صفر.
Exactly. أحسنت، لأنه displacement صفر. Because you started from point 1 and you came back to point 1. If you go back to the same point that you started from, we call it a closed path. Now in the example, he tells me that the work done by that force F equals to 60 joules. طيب. Can you tell me if this force F is a conservative force or a non-conservative force, depending on what I have just said? Conservative ولا non-conservative?
Non-conservative.
نعم، أحسنت. It's a non-conservative force. يعني قوة غير محافظة. طيب why? Why is it a non-conservative force?
مقدار
الورك
إن الورك شو ماله؟ The work done around a closed loop equals to 60 joules. It does not equal to 0. And since it is equal to 60 joules, that force cannot be what? Cannot be a conservative force. لو إنها كانت conservative force, the work done in moving from 1 to 2 and then back to 1 should be what? Should be 0. So immediately you know that this force is not what? Is not a conservative force. تمام? Okay. Let's go back to the work kinetic energy theorem and extend it a little bit more. يعني خلينا نتعمق فيها شوي. Remember, we said before that the kinetic energy theorem says the following: that the total work done on an object, which we called W net, you can call it W total if you like, equals to delta K. Remind me, what is delta K? شو يعني delta K هاي؟ Who can tell me? What is delta K? شو متأكدين في حد عندي بالجهة الثانية؟
تغير بالطاقة الحركية.
Yes, change in kinetic energy. Yes, it's the change in kinetic energy. So the total work done on an object equals to the change in the kinetic energy. طيب. هذا total work done, and I have explained exactly what W net is. It's work done on the object by all forces acting on it. هذول الforces can be conservative or can be non-conservative. W net, I can divide it into two parts. A work that is done by the non-conservative forces, which is defined here, and work that is done by the conservative forces, which is defined here. So W net is the sum of W non-conservative, which is the work done by non-conservative forces, plus W C, which is the work done by conservative forces. Which is this is normal and natural. Take this mass, for example. There is a force F moving it up the incline, and there is the weight acting on it, which I resolved into two components, and there is the frictional force. Now tell me which of those forces, F, the weight, and K, which of them is not a conservative force? مين منهم بمعنى آخر non-conservative force?
Friction.
F is non-conservative force. Fk is a non-conservative force. The weight, however, is a conservative force. So as this object moves, F does work. I call it W non-conservative because it is due to a non-conservative force. If K does work, برضه بيجي تحت W non-conservative. لكن the work done by the weight, under what does it become? non-conservative ولا W conservative؟
W conservative.
Yes, أكيد W conservative. So W non-conservative plus W conservative equals to delta K, which is the change in kinetic energy. Remember, delta always means final minus initial. طيب, remember from also last lecture that the work done by a conservative force, WC, always equals to the negative of the change in potential energy. WC always equals to minus delta U. طيب, evaluate for WC. We get now W non-conservative as before. Instead of WC, I will evaluate minus delta U should be equal to delta K. Take delta U to the other side, you get that the work done by non-conservative forces equals to the change in potential energy plus the change in what? Kinetic energy. Change in potential plus change in what? In kinetic. Remember, delta means change. So this is one of the most beautiful formulas that you can see in mechanics, which says the following. The change in potential energy for an object plus the change in its kinetic energy equals to what? Equals to the work done by non-conservative forces. يعني تغير في طاقة الوضع زائد التغير في طاقة الحركة يساوي مين؟ شغل القوة غير المحافظة. What is so beautiful about this formula is that all the questions we have done before, except those that ask for time, ما عدا اللي بيسألوا عن وقت, can be done using this formula. يعني if you are not really good at using equations of motion in one dimension, or using Newton's laws and then equations of motion, you can use this formula. It does probably more than 95% of the problems. You can solve it using this formula. And I will show you how to do that. So you must take an advantage of this. In the exam, you can solve the question using this or the equations of motion. It's up to you. Okay? Nobody sees, or we don't really ask you to do the question in any specific way. But we need to understand what it means. This is what we are going to do now. Before we use this formula, let us see what we mean by conservation of total mechanical energy. في مصطلح اسمه total mechanical energy، يعني الطاقة الميكانيكية الكلية. Total mechanical energy. So how do we define it? Total mechanical energy, I represent it as E. Total mechanical energy is defined as E, which is the total mechanical energy, equals to K, which is the kinetic energy, plus U, which is the potential energy. For E equals to K plus U. This is what we mean by the total mechanical energy. For any object, if you add up its kinetic energy and potential energy, you get what we call total mechanical energy. That's what we mean by total mechanical energy. So what do we mean now by conservation of total mechanical energy? I cannot understand conservation of total mechanical energy unless I know what total mechanical energy is. That's why I defined it first. Okay, let's see what we mean by total mechanical energy being conserved. Now, if no non-conservative forces are present, يعني إذا ما عندنا قوة غير محافظة. طيب, إذا ما عندنا قوة غير محافظة, this means the work done by non-conservative forces equals to zero. This is what it means, as simple as that. Then no work done is by non-conservative forces, and therefore W non-conservative equals to zero. Why? Maybe you don't have non-conservative forces, or even if you had non-conservative forces, their work equals to zero. We will see this example in a minute. What I care about is that this W in C equals to what? Equals to zero. بدي واحد فيكم بس give me a situation where only conservative forces act. أعطيني وضع بس بيكون في قوة محافظة بتأثر. Shall I help you؟
جرافيتيشنال
ايوه اللي هي شو بنسميها؟
فري فول
fall.
Free fall.
free fall. نعم السقوط الحر. سقوط الحر only the force of the weight acts, which is the gravitational force. هاي conservative ولا non-conservative? It's a conservative force. Therefore, we get, if you don't have work done by none, you have that delta K plus delta U equals to what? هي الأصل W non-conservative. But W non-conservative equals to what? 0. So what does this mean? It means that if only conservative forces act, the change in the kinetic energy, لاحظوا change in kinetic energy plus change in potential energy equals to what? To 0. This means that if the kinetic energy increases by 100 joules, what happens to the potential energy so that the sum is 0?
Decreases by 100 joules.
If delta K is plus 100, delta U must be what? Minus 100. So that they add up to 0. So any increase in delta K, tamam, opposite to it, there is a decrease in what? In delta U. If delta K increases by X, delta U decreases by X, so that the sum is what? Is 0. If delta K is, let's suppose delta K is minus 100 joules. Tell me, what should delta U be?
100.
100. So that minus 100 plus 100 equals to what? Equals to 0. طيب, I will always be using this formula. But just to make you understand what we mean by conservation of energy, let me write the following. Delta K is basically K final plus delta U is U final minus U initial. Yani final kinetic energy minus initial kinetic energy gives delta K. Final potential energy minus initial potential energy gives delta U. And that all equals to 0 when W non-conservative equals to 0. So put final together and initial together, you get K final plus U final together, minus you have K initial and U initial. All that equals to what? To 0. But we know that K plus U is E. Since final and final, we get E final. So this means that the final total mechanical energy, يعني الطاقة الميكانيكية الكلية النهائية, minus the initial total mechanical energy equals to what? Equals to 0. Therefore, E final equals to what? E initial. In other words, the total mechanical energy does not change. It remains what? It remains constant. Whenever something remains constant, we call it what? Conserved. محفوظ. ليش محفوظ? Because it does not change. ولذلك we call it conserved. This is what we mean by conservation of total mechanical what? Energy. Look at this very simple example. We have an object at a height h above the ground. Initially, it had an initial speed of 0. Like, tell me at this point, what energy does it have? Kinetic or potential energy?
potential.
Now, it's potential energy. طب ليش it does not have kinetic energy?
It's not moving.
لأنه its speed is 0. It's not moving. أحسنت. Yes, it's not moving. طيب, إذا U initial equals to mg times h, and K initial equals to what? To 0. Therefore, I can say that E initial equals to mgh plus what? Plus 0. And this will be equal to mg times what? Times h. Now, tell me, as it falls down, what happens as it falls down?
The kinetic energy increase.
Kinetic energy, أحسنتي, starts to increase. طب potential energy?
Decrease.
ممتازين. طيب, Suppose that the kinetic energy increased by 20 joules. تمام. What is delta U? What is the change in potential energy? إذا delta K plus 20 delta U شو بدها تساوي؟
minus 20.
minus 20. نعم. يعني in other words any loss in potential energy اللي بنخسره في البوتنشال energy, where does it go? As kinetic energy. يعني اللي بتخسره من البوتنشال is converted into what? Kinetic. تمام؟ يعني if you lose 100 joules of potential energy, it means that you gain joules of what? Of kinetic energy. So delta K is plus 100, and delta U is what? Is minus 100, so that their sum is what? Is 0. Now, as it continues to move down, kinetic energy continues to increase, potential energy continues to decrease until you get to this point where you have the maximum energy as kinetic, while the potential energy is 0. Why is 0 with respect to this level? Because it is exactly on the same level. There is no H. H is 0. So U final equals to 0, and K final equals to half mv squared. طيب, what is the final mechanical energy? I say that E final equals to half mv final squared plus what? Plus 0. ليش 0? My potential energy 0 at this point. And what does conservation of total mechanical energy says? It says the following, that E final, which is this, must be equal to E initial, which is this, mgh. So I get that mgh equals to half mv final squared. This is what we call conservation of total mechanical energy. Whatever you lose in potential energy is gained as what? As kinetic energy. Now, if it's moving up, the other thing happens. The reverse happens. Yani, as it moves up, potential energy increases and kinetic energy what? Decreases. As you move down, kinetic energy increases and potential energy what? Decreases. Okay, I have made a simulation for this. عملت simulation له using Flash MX. I'm not sure هي برضه موجودة على e-learning site. Look at this. This is a ball. It's rising up until it gets the maximum height and starts to fall back down again until it gets back to the ground. تمام? And then it's moving up. As it moves up, what increases? Kinetic or potential?
Potential.
Potential increases as it's moving up. تمام. هيا, it's moving up now. Land moving up معناته potential increases and kinetic what? Decreases. Look at this. In red, the length of this bar means potential energy. The red bar means potential energy. طيب والblue bar شو بيعني؟ Kinetic energy. الآن as it moves up, potential increases معناته the length of the red bar increases. تمام. And the length of the blue bar what? Decreases. Okay. Look at this. هاي شايفين هذا increases while the blue bar what? Decreases. طيب, tell me what is this here? This color. What does that represent?
Mechanical energy.
أيوة, total mechanical energy. Does it change? It's the same. Because it's the sum of this red plus this blue, which is always equal to what? Equal to this height. Hey. ليش؟ لأنه total mechanical energy is conserved because only the gravitational force acts. Look at this. See how it changes. هذا كله potential صار at maximum height. Now potential decreases, kinetic increases. Okay. Now it all becomes kinetic. Then it goes down. It all becomes potential and so on. But the sum of the red plus the blue is what? Is constant and equals to what? Equals to this, which is what? Which is the total mechanical energy. واضحة هاي? Okay. You see that? If you stop it here, this height, red, which is potential, plus this height, blue, which is kinetic, is always equal to this. which is constant. هذا موجود عندكم. It is on the e-learning site. I spend a lot of time doing these simulations. It is worth looking at them. They're extremely useful for you. Okay. But as I said, you need Flash Player to play them. Okay. I will show you another one later on. Let's go back. So conservation of total mechanical energy means there is no loss of total mechanical energy. يعني ما في خسران في مين؟ في الطاقة. Therefore, we say total mechanical energy is conserved. يعني محفوظة. E final minus E initial equals 2. I can call it delta E since it's final minus initial, and this and that equals to 0 when no non-conservative forces are present or when their work is equal to 0. I've taken this from your book, this which is similar to the flash file I have just shown to you. There is someone here, he's holding an object. This object is at rest. It is at a height h around. So all the energy it has at this point is potential energy. Now, as it starts to move down, potential decreases and kinetic what? Increases. When at this point, all the energy that it had here has become kinetic and the potential equals to what? To 0. So as it comes down, as we said before, potential energy decreases, kinetic energy increases, but the change in kinetic energy, which is positive, plus the change in the potential energy, which is negative as it moves down, if you sum them, you get what? You get 0. You can also state this as following. You see, as the ball falls, only the gravitational force mg, which is a conservative force, acts. Therefore, u decreases while k increases, but k plus u is what? Is constant, which is the total mechanical energy. Okay. But I always, if you like to use this, you can. I always like to use delta k plus delta u. I always prefer to use the changes in the quantities. And if you have, and basically you get this from this formula anyway, as I showed you above. If you have no non-conservative, get that delta k plus delta u equals to 0. Now, the only way to understand what I have just said really well and be able to answer questions, you have to do questions. You have to do as many examples as you can. It is not enough to read the notes. Okay? You need to strengthen this, to support this by doing questions. And let us take the first example. It says the following. An object of mass m is dropped. لما يحكي لك dropped, what does it mean? What does it tell you, the word dropped?
It was at rest.
Yes, it started from an initial speed of 0. That's what it means, yes. From a height of 15 meters. يعني احنا, we dropped it from a height of 15 meters from here. Its initial speed is 0. طيب, above the ground. And we dropped it from a distance of 15 meters above the ground. Ignoring air resistance. يعني اهمل مقاومة الهواء. Now, this means that we only have the force of the weight acting. W non-conservative. في شغل قوة غير محافظة. Do we have W non-conservative? The answer is no, because you have no friction, you have no tension, you have no non-conservative force. So the work done by non-conservative force is 0. What does he want? He wants us to find the speed of this stone or this object just before it hits the ground. From a height of what? Of 15 meters, starting from where? From an initial speed of 0. Okay. Now, since we have no non-conservative forces acting, we can say that delta k plus delta u equals to what? Equals to 0. Now, it's simple to deal with delta k. It is half mv final squared minus half mv initial squared. We have to be slightly careful about delta u. So how do we go about dealing with delta u? If you follow this, you will never go wrong. Let's say the following. For delta U, if object rises يعني يرتفع، إذا كان الجسم يرتفع, then delta U is positive, equals to plus mg times h. When the object moves up, or when its elevation has increased. When its height above a given level increases, we have mgh. طيب هيا لاحظين it's increasing, it's going up. طب what if it is descending, descends؟ شو يعني descends؟ يعني falls، يعني يسقط. Then delta U is what? Is minus mg times what? Times h. Delta U is minus mg في h. طيب what happens when the object does not rise and does not fall? In other words, it's moving horizontally. If you move horizontally, does the height change? Horizontal motion? No. The answer is no. Then delta U equals to what? Equals to 0. Delta U equals to 0. If there is no change in what? If there is no change in height. If you go with this, you will never go wrong. So let's do this question. Delta K plus delta U equals to 0. Delta K is half m V final squared minus V initial squared. Then comes to delta U. Now, the object, did it descend or ascend? هو انخفض ولا
Descend.
ارتفع؟ Descend. شو بنحط إذن؟ Minus mg times. What is the distance that it descended by? How much distance did it descend by? 15 meters, because he wants the velocity or the speed just before it hits the ground. معناها it has descended 15 meters. So minus mg times 15 equals to 0. The only unknown is V final, and you get V final equals to 17.1 meters per second. You see, the whole question is done in one line. You can do it using equations of motion. You take an origin and you take a positive direction for your vectors and so on. If you like, you can do it that way. But there is an alternative way now, which is easier, which is delta K plus delta U equals to what? Equals to 0. So this is one example. Let's have another example. A stone is projected vertically upwards from ground level. Yani we projected the stone from this ground level. Okay, we projected it from the ground level with an initial speed of 20 meters per second. Initial speed 20 meters per second. What is the maximum height? Also, this question can be done using equations of motion. And I also did it using W total equals to delta K. I will use it with this, which is really comes from W total equals to delta K, using delta K plus delta U equals to what? Equals to 0. So delta K is half m. What is V final at maximum height? It is 0 minus V initial 20 squared. Now the object, did it descend or ascend? Did it ascend or descend? ارتفع ولا انخفض؟
ascend.
Plus mg times y max equal to 0. What happens to m's? Cancel out, and immediately you get that y max equals to 20 meters. You can do it using the equations of motion, and you will get the same answer. Let me take another example. Remember, we did this type of question. We used to ask for the acceleration of the system and the tension in the wires. Now he's asking the following. Find the speed of mass m1, which is this one, when it has fallen a vertical distance of 2 meters. يعني أوجد سرعة m1 بعد أن تسقط مسافة كم؟ 2 متر. يعني 2 meters. This goes down by 2 meters, and this goes to the right by 2 meters. ليش? Because they are connected together with an inextensible string. تمام? With an inextensible string. They have the same speed. Why? Because they are connected by this wire. Their speeds are the same. When a car pulls another car, they have the same speed because they are connected by an inextensible wire. طيب how do we find this goes down, this goes to the right? How do we find the speed of mass m1, which is really the same as the speed of mass m2, when m1 has moved 2 meters down? Now, if m1 moves 2 meters down, this means immediately that m2 moves 2 meters to the right. Check, moves 2 meters to the right. How do we do that? Now, I can use delta k plus delta u equals to 0. Right. How many objects do I have? I have 2 objects or 2 masses, m2 and m1. I must apply delta k plus delta u to each one. So I get delta k1 plus delta u1 for the first, and delta k2 plus delta u2 for what? For the second. And this equals to what? To 0. Okay? This is for mass 1 and for mass 2. You must have those for any mass you have. I have 2 masses, I have 2 of them. Type. For mass 1, delta k is half m1, v1 final squared minus v1 initial squared. Now we come to delta u. Now it has moved down. Yani it descended. Yani delta u for mass 1 is negative. So it's minus m1g times the 2 meters times 2 plus for m2. It's half m2 v2 final squared, which is the same as v1 final squared, because as I said, they are connected together, minus v2 initial, which is also 0, because it was initially at rest. The system in the question says the system started from rest. Then delta u2, which is the change in the potential energy of mass 2, what does it equal to? It moved on a horizontal surface.
0.
0. نعم. ليش؟ The height, since m2 does not change height, ما غيرت ارتفاعها. إذا delta u for it equals to 0. Now, just evaluate v1 initial equals to 0. You get this. تمام? And remember that v2 initial and v1 initial are the same. v1 final and v2 final are also the same as speeds. Therefore, I can write them as v1 final equals to v2 final, which equals to v final. Why are the same? Why are they the same in magnitude? Because they are connected by a string. As I said, if you have a car pulling another car, they both will have the same speed. Okay? So now, instead of v1 final and v2 final, we have v final squared, and there is a common factor, m1 plus m2 into half multiplied by that equals to 2m1g, and immediately you get that v final equals to 4m1g divided by m1 plus m2. So this is how you can do this question. You have an alternative way to do it. You can use equations of motion. You can use Newton's second law to find the acceleration of the system as we used to do before. And then after finding the acceleration, you can use the equations of motion and you will get exactly the same answer. And I advise you to do it this way too. Okay? Do you have any question on this example? Right. Just in case any one of you, when you have time, you go back and revise and you look at this and you say, well, the forces that are acting are the weight, it's a conservative force, but tension is not a conservative force. Tension here is also not a conservative force, and N is not a conservative force. So I have 3 non-conservative forces. How did I use delta K plus delta U equals to 0? كيف أنا استخدمتها؟ مش أنا حكيت هون we always have W non-conservative. طب ما أنا عندي non-conservative forces هون. Why did I write 0 here? Who knows?
عشان تكون
لأنها القوة الأكبر.
لا مش لأنها القوة الأكبر. في a lot more convincing answer.
عشان هي اللي حركتها، هي اللي خلتها تتحرك من الرست.
MG اللي خلتها تتحرك من الرست. طيب let me help you.
لأنه عمودية.
إيش هي العمودية؟
القوة اللي بتأثر عليها.
مين هي؟ احكي لي مين هي. You are on the right track. طلع على
في تنشن.
ان هاي
ان هي اللي بتأثر، بتكون عمودية، ما بتجيب
الآن.
شيء، ما بتأثر.
اوكي يعني you are along the same lines. لاحظوا على ان هاي n acts on m2. Is n a conservative force? No, it's non-conservative force. But what is the work of n as m2 moves to the right? لاحظوا, this is n and this is the displacement. What is the angle? 90 degrees. What is the work of n? 0.
0.
0, exactly. So n does no work, so we have no problem. طيب, go to the tension here. The tension is to the right. صح? And the displacement is also to the right. So this tension, which is non-conservative force, does work. What is the work of this tension? It is T times D times cosine 0. So what is cosine 0? 1. So you get T times D. So this tension does positive work. But look at this. The same magnitude of tension acts up here. And the displacement D is downwards. Tension is upwards. D is downwards. There is an angle of 180 degrees between them. So you get the work equals to, let me say, minus T times D. Where did the minus come from? هذا الماينس اللي هو cosine cosine 180 degrees. So you get W total equals to minus TVD. عفوا, W tension equals to minus TVD. This does an amount of work equals to minus T times D. This does an amount of work equals to plus T times D. So what is the total work done by the tension then? لاحظوا, minus TD plus TD, it equals to what? It equals to 0. So فعلا the work done by the non-conservative forces is 0. So I can use delta K plus delta U equals to 0. With masses connected to pulleys like this, you can easily ignore the tension, provided we don't have friction in the pulley. And all our questions, we don't have friction in the pulley here. واضحة؟ ليش أنا عندي non-conservative forces and I still used the work done by the non-conservative forces equals to 0. Okay. Do you have any question? Right. I explained this over here. What I just said above, I explained it over here. Let me just show you another flash file. You see, this red straight line is the potential energy. This is the kinetic energy. And this is for this ball that's moving up and moving down, moving up and down. The point here means the value of the energy. This one gives you the value of kinetic energy. This one gives the value of potential energy. And this one gives the total mechanical energy. So let me stop it here. Okay. What does this mean? It means that at this height, this is the kinetic energy of the object from here to here. This is the kinetic energy. You can read it off this axis. So what is the potential energy at this height? It's red. You can read it over here. Now, if you add this value to this value, you will get what? You get this. So at any point, whenever you add up the potential energy plus the kinetic energy and you add this to this height, you get what? You get this total height. هذا بيمثل mean the total mechanical energy. Note that it is constant. No matter where it is, at maximum height, 10 meters below maximum height, just before it hits the ground, the total mechanical energy is what? Is constant. Why? Because I am assuming here that we don't have frictional forces, only the weight acts. So the sum of the two values, potential energy plus kinetic energy, always equals to the constant value of the total mechanical energy, which is potential energy, which I call U, and kinetic energy, which I call K. Okay, so you can look at this and just understand what it means. Look at maximum height here. at maximum height. لاحظ maximum height. What is the kinetic energy? 0. What is the potential energy? Maximum. Since 0 kinetic energy, maximum potential energy, this equals to the total mechanical energy. So the total mechanical energy here equals to the potential energy. Now, as starts to move down, okay, لاحظوا شو بصير؟ Potential energy decreases, but at the same time, kinetic energy what? Increases. But their sum is what? واضحة هاي الرسمة؟ It tells you how the potential energy and the kinetic energy change. Remember all the time that their sum is constant and equals to what? Equals to the total mechanical energy. طيب. I can also say that the change in potential energy, the change in kinetic energy equals to what? Equals to the work done by non-conservative forces. If the non-conservative forces do no work, then I get delta K plus delta U equal to what? Equals to 0. Okay. So this flash file, I also have this on the e-learning site, but you need to run it. You need something called Flash MX. Do you have any questions before we break? So any questions? Right, you don't have any questions. So let me stop the recording first.